In this video we are going to see about the insertion, the next method of insertion, that is inserting the new node at the end. Okay, inserting the new node at the end. So here what we are going to do is we are going to use the same condition, that is ptr tends to next is not equal to start. Okay, by using this, what we are doing, we are finding the last node, and what we will do, we will insert the node at the end of the list. Okay, so we will insert the node here, and what are the main things we have to do is we have to change the address part for this. We have to change the address for this here, here, and here we need to change. Okay, we will see the algorithm. So this is the algorithm for inserting the new node at the end. So first we are checking the overflow condition. After we are creating the new node and we are allocating the memory space for the new node. Okay. Then what we are doing, we are assigning the value. So for value, I'm considering it value is equal to 6. Okay, value is equal to 6. Then next what we are doing, so new node, so this is the new node and the value is 6 here. Okay, then what we are doing, new node tends to next is start. Okay, we are new node tends to next, so this is the next part and we are assigning address of the start. So what is the address? For example, I'm giving the address for this is 100 and for this is 150 and for this 200. For understanding, I'm given here. And next is start. So what is the address of the start? It is 100. So that means it is connected like this. Okay. Then next, new node tends to next is start. Then what we are assigning, ptr is equal to start. So this is a start node and we are assigning this as a ptr node. Okay, this as a ptr node. And next we are going to check the condition, ptr tends to next is not equal to start. Okay, we have to check the condition, ptr tends to next is not equal to start. So we are checking the condition, this is the ptr node and we are checking the condition next is not equal to start. So this condition is true. If it is true, means we have to execute the step ptr is equal to ptr tends to next. So this is the ptr node. And again we are checking the next is not a start. Yes, so this is the ptr node. Checking next one. Yes, it is not a ptr. Then next is not a start. Okay, so yes, it is not a start. Then we are checking ptr tends to next is not a start, but it is a start. So the condition becomes false. So what we are doing, ptr tends to next is a new node. So the ptr tends to next. So this is the next part. Here we have to store the address of the new node. So it is 200. Then next, new node tends to previous is equal to ptr. So this is a new node tends to previous, means this particular part, and it is equal to ptr. So what is the address of ptr? 150. So it is 150. The next, new node tends to previous is equal to new node. Sorry, start tends to previous is equal to new node. So this is the start and what is the previous here? So previous is new node. So like this way the node is inserted in the linked list. And we will see the code. So here from here I will write. So the first struct node, they are using two pointers. One is new node and new node, and next one is ptr. So these are the new nodes here. Then next we am declaring one variable int val. It is for storing the value. Then I am using the printf statement. Okay, so printf statement for storing the value, it will print the statement as enter the data. Then by using the scanf statement, we are going to get the value from the user ampersand, and next we have to use the malloc function to allocate the memory space for the new node. So struct node star, then malloc function, then size of struct node, then semicolon. Then next what we are doing, I'm writing here, we are assigning the value, that is new node tends to data is equal to VAL. Okay, then next it is same as the algorithm only. New node tends to next is equal to start. Then we are assigning PTR is equal to start. Then we have to use the while loop, while PTR tends to next is not equal to start. Then we have to assign PTR is equal to, if this condition is true means it will execute the statement PTR is equal to PTR tends to next. If this condition becomes false means it will come out of the loop and it will execute the statement, that is PTR tends to next is equal to new node, then new node tends to previous is equal to PTR, then start tends to previous is equal to new node. And then it will return this chart. Before that you have to write the function. So this is the code for inserting the element at the end.